guys. So this week we're gonna start on a unit on linear functions. So the first thing we're gonna look at is slope. So you may be asking yourself, what is slope? Maybe you've heard of it before. Either way, it's totally cool. So slope basically is it's a rate of change. And it's asking, like, what is the rate that the y's or the outputs are changing in relation to the x's or the inputs of a function? So, like, how fast is the graph or the table or the equation and the inputs and the outputs? How fast is it going to be changing? So, and in what way is it changing? So, this half of the week, we're going to actually be looking at two ways to find slope. So the first one is slope from a table. So the way that you find slope from a table is you basically need a slope is like I said, it's a rate, it's a relation, so that it's a ratio. So it's going to be a fraction. So when we're looking at a table, we're looking at what is the change in y, or the outputs. Over the change in x, or the inputs. Okay, so that means that if I'm given a table, I have to look at how much is this changing and how much is this changing. This is my x and this is my y, and put them in a fraction together. So on the left side, my x's, it's going up by 1, right? So it's positive 1, and it's like that every time. Over here, I'm going up by 6 every time. So in this case, the change in y, how much it's changing, how much the y's are changing is 6, and the change in x is 1. So my slope is just going to be 6. And just, if it's linear, if it has a slope, it should always be a constant change. Okay, linears either increase, decrease, or stay constant at a constant rate. So that means that, like, the slope shouldn't be changing between each point. Then it would be something else. Okay, so here we go. This one's I've got x and y here. So I have to look at how much I'm changing. So here it goes up by 2, which is the same every time. And here I'm going up by, 16. I'm adding 16 every time I go up in the table. So remember, it's the change in y over the change in x. People always look at the table and they want to put the x on top. It's actually the y goes on top and the x goes on the bottom. So in this case, the rate of change is 8. So you go up 8 packs for every box. I don't know packs of what or boxes of what, but you get the idea. Okay. And then whatever this one's talking about is cost per minute. So this is going to be my x and this is going to be my y. So my x's here is going up by 12. And then again, going up by 12 every time. And then down here, I'm going up by 500. So it is a constant rate. It's changing the same. So my slope is going to be the change in y over the change in x. So I can't off the top of my head think what that reduces down to. So I'm just going to reduce it kind of slowly. One way to do this is like for example, those are both even numbers. So I know that they're both divisible by 2. So I can reduce it by 2 real easily, right? 250 over 6. And then, hey, even numbers again. Cool. So I can reduce it again. 125 over 3. 125 is not divisible by 3, and 3 is prime. So that is the simplest version of that fraction. But anyway, and slope should always be in a fraction. You don't really, for graphing, it makes much more sense for graphing, you know, when you use decimals for slope. So basically, whatever this is, the cost, or I'm sorry, the number of minutes that something takes goes up 125 minutes for every $3 in cost. Whatever that means. Sorry, I didn't pull the context with those tables. My bad. Anyway, so remember that slope from a table, you do change in y over change in x. If you're coming from a graph, I'm sure you probably heard this before. It's rise over run, right? So what you want to do is you want to find 2 points that cross at the corner of one of the boxes on the graph. And you want to make a slope triangle, right? So basically you're connecting the dots by only going on the graph lines, like the actual, like those gray lines that are on there. And then the rise is the up and down part, and the run is side to side. So I want to see how many I go. Now, you got to think if it's going up or right, that'll be positive. If I'm going down or left, that'll be negative. And basically, we read graphs from left to right. So if on the right side, if it's pointed down, your slope should be negative. So anyway, from this point, I went down 1, 2, 3, 4 spaces. That's going to be a -4. And I went right 1, 2, 3, 4 spaces. So my slope is going to be -4/4, which simplifies down to 1. -1. Okay, then got another one. Same thing. Here's my 2 points already drawn for me. So I'm gonna do rise over run. So I go down 1, 2, 3, 4, 5, and I go. So it's -5, and I go right 1, 2, 3. So my slope is -5/3, and that doesn't reduce or simplify or anything. So my slope is just -5/3. Last one. To go from here to here, I go up 1, 2, and right 3 spaces. So 1, 2, 1, 2, 3. So my slope is going to be +2/3. Hooray. Anyway, so that's all we're doing for this half of the week, kind of easing into linear functions. I will see you guys at the live meet.